So for this example, we want to use the GDP and emissions data to compute the value R to describe the linear correlation between them. So if we want to do what the book wants us to do and do this by hand, we get something like this, where you can see that we would take our two data sets, get the products, take the sum of the products, take the sum of each, take the sum of each squared, and then plug all of those into that monstrous guy there, R, with some squares and some radicals, and you push it around. But I said you have better things to do with your time anyway. And really what I'd recommend doing there is using one of those linear regression functions. We're going to see that there are a few of them in the calculator that can get you to this point with R, among other things that we'll see as we go on. But most importantly for us right now, whichever one you happen to get most comfortable with, whichever one you like the most, whichever one gets you what you need, what you should end up with is that the value for R in this case, the correlation coefficient, is about 0.874. So about 87%, which fits with what our scatter plot from earlier said, that there is strong positive correlation, because that value is somewhat close to 1. We'll see you can get closer than that, you can get fairly closer than that, but 87%, that's actually pretty good. Don't just take my word for it, though. And hopefully at this point you learned that I'm not always going to be entirely honest with these things. I sometimes will oversell it a little bit for effect. So if you want to figure out whether or not that really means anything, we'll see next that we have a procedure for testing these correlation coefficients. The procedure is going to be a little bit familiar. This will continue.